Hello, everyone, and welcome to today's webinar on an assessment of a non-invasive low-cost gas submeter. Before we get started, I'm going to review just a few webinar logistics. Today's webinar, you'll all be in listen-only mode, and you can submit questions by using the Q&A button on the bottom of your screen. And you don't need to wait until the end of the presentations to submit your questions. In fact, we encourage you to submit them well in advance of the Q&A session. Today's webinar is based on an evaluation by the National Renewable Energy Laboratory, and you can find the full report as well as summary documents on gsa.gov. And we'll also be posting links in the Q&A panel. Today's webinar is being recorded and it will be shared with you all. And you can find the presentation slides and recordings for all of our webinars at gsa.gov. And you can also access the webinar recordings on our YouTube channel. A quick rundown of today's agenda. First, we'll hear from Kevin Powell, the Director of the Center for Emerging Building Technologies. Next, we'll hear from Sean Pashuta, a research engineer at the National Renewable Energy Laboratory, who will describe the field validation of the gas submeter. And then we'll get some on-the-ground feedback from Joshua Banis. And finally, we should have plenty of time for Q&A. And with that, I'd like to turn it over to you, Kevin. Thanks again for all of you for being here.
Yes, and I want to thank you, Andrea, for organizing the webinar, for the whole team for having completed actually a rather quick assessment for GPG. That is to say, got this done in about a year. And we think this is just it's a technology that is very low cost with huge potential for our agency. So just at the highest of levels, why do we care? And it is true for sure that we're looking to electrify our buildings. Everybody's heard that, move towards net zero operations, which does not really include the on-site burning of fossil fuels. That said, we recognize that fossil fuels are a key part of our existing facilities, and managing them in the most efficient way possible is what we really want to do. Not only is there a lot of challenge around just the carbon pollution of burning these fuels, leaks, natural gas leaks are just, the global warming potential from leaked natural gas is way, way larger. In fact, as you can see here, 34 times larger than the CO2 emissions of burning it. So what this technology does is it can detect gas anomalies, prevent the overuse or misuse of gas. It can run the buildings more efficiently using, again, we have real-time, high-resolution data. That's what this does. Having that in real time, that gas metering data really enables us to be a lot more efficient. What you measure is what you can manage to. And then, of course, there's a whole host of meeting policy goals and providing data for ESA reporting requirements. So with that, I guess next slide here. And I'm going to turn this over to Sean Pashuta, who led the study for us at the National Renewable Energy Lab, NREL. Sean, among other things, he's of course an extraordinary researcher, and he's also, because he lives in Colorado, no doubt, an avid skier. So let us go zooming down this double black diamond run, Sean.
Okay, hello everyone. Thank you, Kevin. So yeah, I did the evaluation along with the GSA team of this non-invasive low-cost gas submeter. And as you see, there's two different photos here. We have on the left a utility meter. It's a utility gas meter. And what you see there is kind of the simplicity of this product we're evaluating. However, that is not the entire product. That is simply the strap-on sensor probe. And so I'll get into a little bit more detail about that on the next slide. However, you also see the meter we used in practice for this project on the right for the report, which you can see the strap to hold on that probe in that photo. However, I wanted to include this one on the left because it really shows, two different options of how easy it is to strap on this non-invasive, low-cost gas submeter or sensor. Next slide, please. And so what is a non-invasive gas submeter? It's basically, as I kind of said it, you strap on a probe to a utility meter, and this probe measures differences in the magnetic field, oscillations in the magnetic field, sends it to a sensor, which translates all that data and pushes it to a BAS. Now, in this case, the BAS could or doesn't need to be a BAS. The sensor could push data to a JACE, a controller, any Internet of Things controller, a BAS, an on-site gateway, you name it, and it's likely that this product can push data to it. And what this allows for is improved visibility. When you have utility meters that aren't smart, you can strap this on, non-invasive, and kind of just start reading data at that point. Next slide, please. Now, from this specific vendor, the vendor is Vataverx, and the infographic on the last slide is basically how it works, how we connect it. And this product specifically, according to the vendor, is compatible with greater than 95% of existing utility gas meters. And that includes diaphragm meters, rotary, and most turbine meters. And as Kevin kind of said, we can use this to detect anomalies in use, overuse, or misuse of gas, potential leaks. You can run buildings more efficiently. And this product will help meet ESA reporting requirements and provide data to anyone who's looking to gather more insight into the consumption of a building. Next slide, please. As far as vendor noted product features from Vataverx, the product has many different data communication options. As you see, a few Modbus there, Pulse, HTTP, there's an onboard logger with this. And also, according to the vendor, there are more data communication options coming. They're working on developing a few more there. So as far as the resolution of this product, it will be meter dependent, but it can be adjusted and measured for the customer's needs. And they do have a high resolution option, which can be up to 100 times greater than the standard high resolution product. Next slide, please. For this project, we GSA and as well as myself chose two different testbed facilities. We have the A. Maceo Smith Federal Building and the Dallas Terminal Annex Federal Building. So both are about 200,000 square feet, and both are office buildings, pretty much constructed in 1971 for the Smith Building and constructed in 1937 for the Terminal Annex Building, which, if you've been on previous GSA webinars, we did another study at the Dallas Terminal Annex Federal Building, and there have been some renovations since 1937. So I do want to point that out. Next slide, please. As far as the evaluation framework, the schedule, we planned for this evaluation to be a 6-month period, and I'll jump into reasons why we don't have a full 6-month worth of data for this. Kind of a spoiler alert there, but the accuracy was measured by comparing interval data to manual meter reads. So we had someone at the facility go to the meter at specific times, take photos of it, which is what you kind of see on the right there. There's timestamps on each of those photos. And then we record all that data, compare it to the new interval data from the vendor's submeter sensor option. And the evaluation method we used here for measuring the accuracy was the absolute mean error. And the data quality and number of dropouts were included or recorded in this assessment. Now, as you see, this is pretty old meter on the right. We're getting different gauges that rotate to show the amount of gas consumption. And so a lot of buildings, especially if they're older, don't have any form of smart meter that provides interval data that is available from the utility. And so this product can help improve that and make it easy to turn your normal meter into a smart meter. Next slide, please. These are the results as well as the performance objectives and success criteria. So we assessed 3 different performance objectives: the strap-on sensor accuracy, the installation and integration, and the cost effectiveness of this product. So the success criteria for each was, we wanted the strap-on sensor to be less than 3% error, and we wanted recordings for 90% of the time. So meaning very low data dropouts. So the results for this performance objective, we saw less than 1% error, which is pretty good when we're doing the absolute mean error assessment. We have the terminal annex 0.77%, and the Smith building, we have 0.95%. Now, you might not see the 90% of the time in here. That is because we never had a data dropout during the evaluation period. So we had connectivity the entire time. The installation and integration, which I'll get into in the following slides, but less than 30 days to install and integrate this option. For the Dallas building, we had 2 weeks, which was 14 days. And the Smith building, we had 6 weeks, which was 45 days. Now, the Smith building, you might think it exceeded that. However, that is no fault of the vendor. We used 2 different options, and I'll get into that in a bit. But the 6 weeks was exceeded due to complications, not at the vendor's fault. And the cost effectiveness performance objective, we wanted this to be less than $10,000 to $30,000, including installation and equipment costs. Previous options used by GSA had been in that price range, which, in my opinion, is pretty expensive. So the install costs here was about $3,000 for both locations. Next slide, please. As far as the accuracy, this is just kind of a different way to put those results. So we have an average accuracy for the Dallas building of 99.23% and the Smith building 99.05%. The largest difference we saw at these buildings was just about 2% for both, which is pretty good. This is just the largest difference any reading during the entire period. And the number of days we evaluated in the data was 48. Now, I know we mentioned the evaluation period being 6 months. However, this was a 6-month-long project, which included the installation and integration time, as well as the calibration. Now, we did have some lessons learned from this, and we wanted the data or number of days to be evaluated to be a little bit longer. However, due to the time when we installed these meters, there was low gas flow in the building. And so calibration of the product, due to the extremely low gas flow, took a little bit longer than expected. We needed a little bit greater of time from day to day to adjust, or instead of day to day, we had to go basically week to week to adjust the calibration of the meter to narrow in the accuracy. And then we could move forward with the evaluation of that accuracy. So there was a little calibration lesson learned from the GSA and NREL side of things. Next slide, please. This is a straightforward, very quick installation. As far as the on-site connection of the device, this is the same photo as before. You strap on the sensor probe. That was installed in 1 day. So this then connects to the sensor device. And that was all pretty easy to install, but we did use 2 different methods here. At the terminal annex building, we used GSA staff to install the strap-on sensor option. And at the Smith building, we used a contractor. Now, the part of the 48-day evaluation, we wanted that to be a little bit longer. GSA, and they had a little bit of trouble finding a contractor that would be qualified and willing to do the work, since this is such an easy job. it was a little bit difficult to find someone to do that. And during calibration and installation, we're trying to test the meter. We found bad cabling was installed, or potentially bad cabling, because we kept seeing the product disconnecting. And we chose a few different troubleshooting methods. And eventually, once we replaced the cabling from the contractor who installed it, we found no issues with connectivity moving forward with the product. So just something to note, make sure you're always using a qualified contractor. And at the terminal annex building, we didn't see these issues. However, Joshua can speak to this in further detail. I do want to note that this product is pretty cool. Typically, you have to install an intrinsic barrier for a gas meter. And with this product, it just straps on, no plumbers, pipe cutting, any dangerous things were needed, which I do always support hiring a qualified professional. However, it is easier than most other submetering options. Now, those options, the other options, can be dangerous to install because of just the technology that's out there. This just straps right on. So that was a positive for this evaluation. Next slide, please. Now, I did touch base on this a little bit. The calibration that calls for adjusting something which is called the K factor. The K factor is basically kind of a multiplier when you're installing a submeter. And this requires comparing the time series data to the utility meter reads. And if something seems off, you adjust that K factor and then reevaluate the results to narrow in the accuracy of the meter. Now, as I said, we did this during low gas flow, so we didn't have a lot of data to work with. And so it took a little bit more time than expected to adjust that K factor. Now you can adjust the K factor. In some cases with GSA here, it did require the staff to physically go to the meter. However, the vendor does offer different options to avoid that issue, which was part of some of the focus group results, which Joshua can get into. Now, the adjustments can be made to improve the accuracy, and once we narrowed it in, data started flowing, and we didn't need to calibrate anything else. I do want to mention that with multiple types of utility meters, the vendor does offer instructions on adjusting these K factors, installation, and they were very helpful throughout this process. So we did find, though, that there was slight confusion in the instructions, and the vendor actually adjusted them to make it more simple and an easy process. So yeah, that was nice of them to do that. Next slide, please. So we found this product to be 70 to 90% cheaper than the previous gas submeters that GSA had installed. The price, as you see here, $3,000 about for each location, whether you use GSA staff or you use a contractor. For the ultra high resolution option, so that is the upgraded option, the material cost was $757, and then you see about $2,000 for installation. There is no SaaS fee with this vendor product, and these prices include everything, the installation, technology costs, and calibration there. Next slide, please. As far as deployment recommendations, it was recommended that, or is recommended that this product be installed at buildings with a need for whole building gas or potentially water meters. We are in the works of trying to build out testing the water capability of this. So this strap-on submeter actually can do gas and water, which I neglected to mention before, but the evaluation here was specifically gas, and hopefully in the future we'll do another project where we can evaluate the water accuracy here. Now, this meter can offer the requirements of the Energy Independence and Security Act, ESA, as I previously mentioned, so it's good for that as far as a deployment recommendation. And buildings with a BAS that allow connectivity and integration with submeters are, a great candidate for this option. We can send data directly to those computers or devices. So yeah, overall, this was pretty easy to use, a cheap option, and it, for the most part, met all the success criteria. The product itself actually did. The 6 weeks was exceeded for the 6 weeks installation was exceeded because of a contractor, not because of the vendor product. So pretty successful project here with pretty accurate results. And I will now hand it off to Joshua, who was very helpful in this project, good to work with. And he is the GPG program manager with the Center for Emerging Building Technologies. And he was part of managing this project on the GSA end for the non-invasive gas submetering project. So thank you everyone for listening. And yeah, I'll hand it off to Joshua. Thanks, Joshua.
Thank you, Sean. So afternoon, everyone. So I wanted to talk a little bit first about setup and installation. So in my previous role with Region 7 managing the sustainability program, I worked with our Smart and Sustainable Buildings team, or better referred to in the GSA world as our BAS team. And so myself, our project manager from the BAS team, Bill Winger, one of their equipment specialists, Kevin Olson, we all went to Dallas one day in the morning and we installed this technology ourselves. So we previously had a setup at both of these sites in Dallas to where we had a 2-wire hookup on the pulse head. The utility changed out their meters and we lost connectivity. So we went out there, okay, the old pulse head sitting on the ground, we have a 2-wire hookup. There's already conduit running into the facility. How can we fix this and get this online in a quick and efficient and less costly manner? And Kevin pointed us in this direction to help support a different GPG project. And so we went out there, we got Cat 6 cable. We used the existing conduit line and we ran that cabling into the building and we ran it to the closest Jace at this first site. And we used, in less than one day, it was really a morning. We ran all the cabling, we got the meter mounted on the wall, we got it connected directly to the Jace, and then Bill Winger was gracious enough to do all the programming. So the programming took him approximately an hour, and he worked with the vendor, and the vendor had really great instructions for him on how to program the Modbus registers that we needed. And then Region 7 has the benefit, our whole region is set up on a Tritium Niagara front end. And so he built into the wire sheet a way for us to adjust the K factor remotely. When you're doing any of the programming directly on the vendor's device, it does require a terminal emulator for initial setup. GSA is allowed to use PuTTY. There's others that are used, such as TerraTerm. But we use that terminal emulator, set it up so that it would actually function on our system and assign the correct IP addresses, and then Bill did all the programming. And next slide, please, Andrea. And so it's, integration was that simple. We assigned the proper IP assignments. At the second site, we installed this on a network switch. And so there was a whitelisting process that we had to go through with GSA. We got the device whitelisted. And then, as Sean talked about previously, we did similar process there, but we decided generally with the GSA project, we would have a contractor install this. And so we used a contractor to install the cabling needed to mount the device, to run new conduit so that it would actually fit, and to provide a source of energy in the box that we mounted it to so that we can easily plug it in at a new location. And so they were able to accomplish that in one day. And with the system that we had, Bill did the programming the second time, and he was able to copy and paste from one building to the next in the wire sheet. Next slide, please, Andrea. And so some of the lessons that we learned during this, though, is we need to do this, especially in Texas for gas related things, when we have like boiler usage in the building. So we installed this in December. Texas can still be very hot in December, and I it was in December we installed this and we didn't have boilers running. So that was a lesson learned. It's, as Sean said, this is also used for water uses, and it's easy to have some water usage and calibrate it. But it was harder for us in Texas to actually get this calibrated initially because we didn't have any gas consumption in the building. And there was a difference we found too, and the meter that we used at both sites were compensated gas meters. And so it was better to use this in peak heating season whenever we had a constant flow of gas, just to make sure that we got the best calibration possible and to lower, the delta that we were seeing between the actual meter readings and then what the device was telling us. So allow K-factor adjustment in the BAS was also a best practice, and Bill set that up for us. And that was because you can remote into this device if it's not in a GSA setting, but that portion had to be disabled. And so we couldn't use Telnet or web server in our application. If it's a non-governmental application, you may be able to use that depending on your security requirements of your business, but we weren't able to. And so we had a workaround where we allowed for adjustment of K-factor in the BAS before it produced a result that we trended. And then it will require a terminal emulator for initial setup. So TerraTerm, PuTTY are the two that, TerraTerm is the one the vendor suggested. PuTTY's the one that I was able to use whenever I configured the devices at the two sites, and it worked fine. Next slide, please. So some of the user experience, and this is, we have a lot of BASs. We monitor gas and other things at every site that we have. And so installation integration was easier than expected. It was as simple as running the Cat6 cable, mounting the device on the wall, making sure it was energized, and then connecting it to a network switch or a Jace. And so it was a lot easier than we expected, but the vendor did have great instructions that allowed us to easily program the device. Some of the usefulness of this data, so it was the same information we had before, but it was more consistent, accurate, and available. And it's easy to adjust the K-factor. So if we ever needed an adjustment on a K-factor, or the utility came and replaced a meter, we know now that it's as easy as reinstalling that probe on the new meter, using the information that the vendor provided on the best locations for each meter. And they have a catalog of meters that they've tested, and they found the best locations for the best quality of data that you could provide, and they're able to provide that. So it made it really easy to install, and the information was really useful for us to use. And would you install it at other buildings? And yes. So it's been easy to install. The Region 7 team has used this, and it's going in at a few other sites. And so there's the limit is for us that the chip that they have in their device right now doesn't accept HTTPS, which would allow us to remote in and make some changes to it manually. But with the BAS setup that we have that's regional, it's easy for us to just make changes on that from Fort Worth. Otherwise, it would be your normal BAS tech that's coming to the building, and then they can make local adjustments. And so it's really easy, and the limitation for GSA, it gets canceled out. I feel like there's probably no software updates that are going to be needed. It's a very simplistic device, and it's, just simple and easy to install. Next slide, please, Andrea. So some best practices, select the ultra high resolution submeter. It's a 10% price increase, but the data that it provides you is really valuable, especially when you're looking at consumption of gas at your site and its ability to find anomalies. Work with a single contractor to install the enclosure. Make sure you have a source of energy in the enclosure so you could power the device, and then make sure all the cablings run, and include any of the integration programming that needs to be done. And then best practice for us, a lot of our O&Ms have ongoing BAS subcontractors, and so our O&Ms could work with their BAS subcontractor to easily do the integration during one of their normal monthly visits. Next slide, please, Andrea. So deployment, duplicating this, and I discussed this earlier, it was as simple as copy and paste. So it made our BAS team really happy that they could copy and paste the Modbus registers that they created before, make some minor changes to IP addresses, and then they were able to get this online. And for GSA purposes, this is already remediated and it can be installed on JACEs or network switches with no issue. Next, please. So some common questions that I already had, and this is our install at the Terminal Annex Federal Building. It's some of the questions I had were, is this, can it integrate with Schneider Electric PME, a database, SE meters, any other BAS that allows for Modbus programming? And the answer is yes. And so I would definitely reach out to the vendor and ask them if they have any experience on these, but we found this, any device that you want to integrate it to, BAS related, Internet of Things, that can take Modbus programming and any of the other protocols that Sean spoke about previously, it'll work easily. Next slide, please, Andrea.
Great, thanks, Joshua. With that, we'll go through some of these Q&A, and if we don't get to them all, we will follow up as well with an email with some answers to some of your questions. So first, do you need to notify your utility prior to installing the device? I think this is for you, Joshua.
So I did have a conversation with our utility before I installed it, just to make sure that they didn't have any issues with this, but they didn't have any problem because it was a non-invasive device that has no effect on their ability to meter the consumption that we have in the site. And so it was an easy install, and they said, feel free to install it at any of the sites, and they didn't have an issue. We would recommend that you verify with your local utility, but this is a non-invasive technology that won't disrupt any of the gas flow, so it can be installed at any time.
Great. We had a couple of questions about whether you need an existing meter. So my understanding that this device needs to be connected to an existing standard meter, but others are saying that it can be installed directly on a pipe without a meter close by. Can you clarify?
This specific technology has to be installed on a meter.
And so if someone has 9 buildings on 2 utility meters, and they want to monitor each building, would it help in that situation?
They would be able to install this on the 2 utility meters.
Okay, great. We also have a number of questions on the total installation cost. So for that $3,000, did it include IT integration with the BAS and other data capture systems? And did it include any of the time spent by GSA staff for the installation and programming?
Yes, that estimate was based upon the time that we spent and the programming time that it took our team.
Okay, great. I think this was answered, but I think it's helpful to say again, is there a device that works for water meters?
This device that we tested is also capable of being used on a water meter. Very soon, we're planning on testing this in that use case scenario. And then at a later time, we'd have a follow-up presentation to discuss the results from that study.
Okay, great, thank you. Sean, I think this is a question for you. Does the accuracy error typically occur on the over-reporting side, under-reporting side, or is it equally distributed?
So I actually just checked the results of this, and it's pretty much equally distributed here. I think that, and I'd have to get a confirmation from Joshua, but if you're looking at something that's heavily on the negative or positive side, that's more of a calibration or K-factor adjustment that's needed. And in this scenario, if you're getting positive and negative results that are slightly off from the utility meter read, it's equally distributed, and that means it's calibrated correctly versus it being all positive. That means we probably need to adjust that K-factor. Is that correct, Joshua?
I agree, Sean. Yes.
Okay. Yeah. So equally distributed is the answer there.
Okay, great. Thank you. I think this is also for you, Sean. How far will it send data?
So on the website, or according to the vendor, when we did this study, the sensor probe that's connected to the utility meter can go as far as 200 feet to the actual sensor or box itself. So if that answers the question, I believe that's what they were looking for, because there is the probe and then the sensor itself. So that can go as far as 200 feet.
And I would add that the probe is up to 15 meters, and that probe goes from the utility meter directly to the Vadaworks device. But you can also, from that probe sensor in the initial up to 15 meters, use a coupler and extend up to the Cat 6 distance. So the normal distance for cabling that you would see is kind of where they were going with their response to us, because we had some sites that could have potentially been close to 200 feet. And that's one of the initial things that we did when we tested. We went and walked the site and got a distance on how far our Cat 6 cable run would have to be.
Great, thank you. Do they need to be hardwired, or is there a wireless option?
For this technology, it's hardwired.
Okay, great. And is there, how do you work with a system for a building that doesn't have a BAS?
So there is a pulse option with this technology, and at the first site that we installed it at, we actually installed it into our BAS, but also with the pulse option. And so we put a little analog reader that's connected to the vendor's meter, and it told us the amounts of pulses it was counting. And so we could use that to extrapolate the gas consumption from the pulses that it's counting. Great.
Do you have a time frame for how to get this, how long it took to go through the cybersecurity process? And is it has it already been scanned for other installations?
For GSA usage, it's scanned and cleared. It was one of the faster items that made it through IT remediation. I would like to say less than a month.
Okay. Is there an ability for a longer term assessment adjustment of K factor for greater accuracy, such as annually?
I think that's more so like you have the option. You can adjust the K factor whenever you'd like. So as long as data is flowing and you can compare two data sources to adjust for accuracy, you can adjust that however many times you'd like over whatever time you'd like. So if for this, we were just limited to 6 months for the assessment. And so we adjusted it as frequently as possible to narrow in that accuracy, but we did need gas flow to calibrate it, because if you don't have any gas flow data, you don't have anything to compare it to. So that was the little hiccup for this project. But you could definitely do it annually as long as you had that option connected for an entire year.
And this is another calibration question. So it sounds like the K factor correction is calibrating to the existing gas meter, but how do you know the original meter is accurate, especially when those meters are old?
I guess that's more on the utility end. So this error is, or accuracy is based on what goes through the utility meter itself. So if you are seeing major discrepancies between this result and your utility gas meter, I'd probably recommend contacting your utility, because there's probably something old or wrong with that meter.
Is the device powered via the Cat 6 cable through power over Ethernet?
Joshua, can you answer that one, please?
No, it's not. So you do need to provide a source of energy for the meter.
And are there technical documents such as installation instructions which can be shared for someone's engineer to get an opinion on this?
Yes, the vendor has publicly available technical documents for communication and installation and integration.
Okay. Can you talk about whether the vendor has a data dashboard, or do you need to rely on the BAS front end to access and archive the data?
They collect data directly on the device. It's stored, but you would need to visualize it. You would need to set up something on your own dashboard.
Can you expand on why monitoring of an existing meter is beneficial? Is it primarily for verification of the utilities meter readings?
For our use case, there's some ESA related reasons to measure it, but it's also useful, and you can actually see when your gas is flowing, and it could help identify potential issues and anomalies with consumption. And so for me, there's a value in having the data available, and we would have 15-minute data intervals, and it would help us trend that, okay, when our boilers are running, we have gas running. When our boilers are off, there's no gas running. And so it's the value of the data that you have available to actually make sure you're consuming the correct amount of gas, and it's could be varied based upon your use case.
And have the installed meters provided any savings or uncovered any of those anomalies to date?
And this is probably a tricky question to answer, and this was part of another study that we went into that was previously recorded. And so I would say yes, there has been some things uncovered, but you may have a perfectly running building that it wouldn't uncover anything. So it's a hard question to answer.
Okay. Let's see, someone wants to know if we can get a copy of the slides. We will be sharing the slides as well as a recording. Let's see. I don't know if we have an answer for this, but is there a way to monitor gas usage from a pipe? Are there devices that do that? John and Joshua, I don't know if we know the answer to that.
Well, yeah, I mean, I think we kind of answered that. It's probably difficult to meter it just from a pipe with a solution like this.
And are there other solutions though that do that?
I don't necessarily want to comment on that. I think that there's probably some form of technology out there, but I haven't researched it myself.
And so the question of whether we're providing the vendor information that's mentioned in the slides, the vendor for the technology that was evaluated was Vadaworks.
I think it's spelled out in the slides itself, but that's
yes.
VATA and then Verks with a V, VERKS. And they have a lot of good information on their website that can help answer some of these questions.
Great. And let's see, has there, it sounds like the device requires field calibration. We talked a little bit about this before. Do we have a standard time required to perform this task about how long that calibration takes?
I think that's kind of dependent on the amount of gas flow. But say you have a high gas flow building, you can probably narrow this in if you have 15-minute data and someone's constantly looking at the actual utility meter itself. You could probably narrow in that K factor, within a few hours or a day. You just need to see the flow to be able to figure out how off you might be from the actual consumption. And the vendor does offer instructions to help with that. We just found that narrowing that number to be super accurate, we had to adjust it a couple of times. That's all.
Do we know if there's been any resistance from utility companies not wanting this sensor attached to their meter?
I think Joshua kind of answered that. We didn't see that with this specific project, but every gas utility is different. I know previously with other metering options, utilities were very hesitant to let any invasive option meter be installed. And so this non-invasive might fix that problem. We didn't experience the issue.
Some of these questions, I think, we do know, we talked about the annual calibration that you could do it, but the vendor notes that that's not required, the annual adjustment. there's a question, can we add a meter for the submeter? So would any inline gas meter work with this submetering? I'm not sure if we can answer that.
Yeah, I'm not sure.
Okay, great. I think that's about it. Panelists, you're looking at the questions as well. Are there any other questions here that we haven't answered?
There was one question about highly recommend a backnet option in the future, and we would agree. So we program these using Modbus protocols. It would be helpful if this technology had a backnet option in the future to make it easier, but it was still fairly easy and took less than an hour to do using the current capabilities.
Great. And from anyone else, any final questions before we wrap up? So you all will be receiving a brief survey, and by completing that survey, you can receive continuing education credit. So GSA, for all GSA attendees, you can receive a continuous learning point by completing the survey. And for anyone who's a member of the American Institute of Architects, you're also able to receive a continuing education learning unit. And we will be sharing kind of the top questions and answers. And if you can also follow up with us if you have any other burning questions that didn't get answered. And we'll be sending the recording and slides and Q&A out next week. So thank you all for joining us, and thank you panelists for all the work on this validation.
Big thanks to the NREL team, to the Region 7 team, and of course to our tenfold team for having pulled this all together, and for all of you for having spent an hour with us here.
Great. Thank you. And